in the last lesson, we started to talk about the processes. As a reminder, a process is a program that is being executed. So when I type a command, for example, ls, the shell finds the program for this command and starts executing it. Executing means that this program from the disk is loaded to the memory, and then the CPU starts to follow the instructions. So when it is being executed, it is called a process or a task in Linux. They are interchangeable. We can use either process or task, but process is a more generic term. And we said that a process is started by another process. For example, when I type the command ls, it is the shell process. The shell is the one that is taking the commands and executing them. It is the shell process that is starting the ls process, and so on. So one process can start one or more other processes, which are called children. And each process has a parent process and may have several children processes. All the processes in the Linux system make a hierarchy, and at the top of this hierarchy is the process that is called init, or initial process. So when we start the Linux system, this is the first process that is being executed, and then this one starts executing terminal processes, shell from terminals, shell processes, from shell the processes of the commands, and so on. All the processes of the system. We use the command ps to list to get a list of processes, but this is showing me only my own processes, the processes that are running in this terminal. We see it is this pts1, my terminal. It shows my terminal. If we give the option a, ps a, it shows the processes of all the users. And if I add the option u, it also shows the user in a separate column, and also how much percentage of CPU each process is taking, how much memory, the state of the process, is it running, is it sleeping, and so on, the time it is being executed, and so on. And we said that we can get more help about the command ps itself with ps help. And what we get here, actually, we should add something after the ps help, either simple or list or output, and so on. So let's see a simple, the help about simple options. So we see this option A that we used, which is giving us all the terminals. TTY is short for terminal, including other users. And we also see this option -A, all with a TTY except session leaders. Now, this is a little bit strange, or it is different from the normal, because usually we give the options with a -A, or capital A, or the select. But here with this command ps, we can have also some options that do not start with a minus. And this is because this command itself, ps, is very, very old. It is ancient. It is since the time of Unix, about 60 or 70 years ago, or something like this. Maybe 60 years ago. So at that time, the way of giving options was not standardized yet, but now most of the commands use options that start with a single minus and a single letter, for example, -A, -E, etc., or with a minus minus and then a long word or long words with a description. Now, with this X, it gives also the processes that do not have controlling terminals. So far, with this command ps au, it is listing only the processes that are started from the terminal. If we add the option X as well, then it is going to list the processes that are not connected to a terminal. They do not derive from a terminal. And here are included the system processes as well. And usually for the system processes, it is the root is the user, and so on. So it is a longer list of processes. And if we want to see it page by page, we can use the command less. And exit with quit from less. Okay, actually, let's see something here interesting. The first process in the list is the process with ID 1. This PID is process ID, and there is the process which has the ID 1. This is the root of all the processes that I mentioned before, and it is either SBin init or this one lib systemd systemd. This process. So all the other processes are created from this one. This is the root of all the processes in a Linux system. And usually it is called SBin init, the initial process. But we see that it is a symbolic link. So if we type it with, if we list it with a long listing, we see that /sbin /init actually is a symbolic link to sbin lib systemd. Another command that can list processes is ps3. And as the name of the command implies, it gives a listing of processes, a hierarchical listing of processes, like a tree. And we see that the initial process is systemd, and then from it, network manager has been started, cron, rsyslogd, sshd. These are system processes. And this command ps3 can get the option p. With the option p, it is going to list the process ID as well for each process. For example, here systemd has process ID 70,196. And to list it page by page, we can pipe the output of this command to the command less in order to see it page by page. So, oops. This is the initial process number 1, and all the other processes derive from this one. We can actually list also the processes of one user, of a single user. For example, I am user 1 here, if I add my username here, it is going to list only the processes that belong to user 1. Let me try with user Andri, for example. It is going to list only the processes that belong to user Andri. And actually, they seem almost the same as my processes, but actually the numbers, the process ID is different. For example, SSHD, here is this number, this process ID, and here SSHD is another process because it has a different ID. We can also list processes. So when we say ES3, we get a big list. But if we give also one process ID, for example, I'm going to give this process ID, then it is going to list only this branch of the tree. 17196. So it is going to list only the branch of the tree that starts with this process, with the process with this ID. Another command that shows processes is the command top. This is actually a dynamic command. It is refreshed after a few seconds. For example, after 2 or 3 seconds, it is redisplayed. The information here is redisplayed. Here we see a list of processes, but at the top of this list are the processes that are more active, the processes that are consuming more CPU and memory. So that's why it is called top, because with this command we see or we discover which are the processes that are more active right now in the system, that are consuming more resources. And there are these top lines as well at the top that give some summary information. For example, this percentage CPU shows how much of CPU in percentage is being used. And this US is by the user processes. This SY is by the system processes, and so on. And also about how much memory and swap is being used. This is the total amount of memory. This is how much is free, how much is used, etc. And the same for the swap. The swap is almost unused right now. Very little used. And to exit from this command or to quit from it, we type Q as usual. There are lots of commands that we quit from them by typing Q. Now, I mentioned before that when we type a command at the prompt, then the shell is starting a new process, and then it is waiting until this process is finished, and then we get the prompt again to give another command. For example, let's see the command sleep 100. It is going to sleep 100 seconds. This is what this command does, and so the shell is waiting and waiting and waiting until the command finishes. And when the command is finished, it will display the prompt. But actually, we can interrupt this process by the process that is running in the shell by typing Control-C. So by typing Control-C, we interrupt the process that is currently running in the shell. And we can think for Control C as cancel or terminate. Now, if we append an ampersand at the end of a command, we need a space and then append ampersand. Then we are telling the shell to run this command in background. So the process will continue to run, but we will get the prompt immediately, and we can type other commands. But the command is still running, but it is running in the background. For example, if we type ps, we will see this command sleep, that it is still running in the background. Or we can use the command jobs to see the programs that are running in the background. So the jobs are the programs that are running in the background, and we see that it is this this job which is still running. And this job has this number 1, and we can bring this job in the foreground using the command fg. Fg is foreground, and then %1, which is the number of the job here. And when we do this, then the job that was running in the background, now it is running in the foreground. And then we can press Control C to stop it or to interrupt it. We can also do the reverse. So a process that is running in the foreground, we can stop, and then we can place it. We can start it in the background. For example, I am starting this command sleep 200. It will wait for 200 seconds. This command right now is running in the foreground, but if I press Control Z, then this job is stopped, and the command jobs shows that this command sleep 200 is stopped. And now I can give the command background %1 to start this command in the background. And if I check with jobs, now the same command, now it is running. Before this command, it was stopped, because we stopped it with Control Z. So with Control Z, we stop a program that is running in the foreground, and then we can start it in the background with the command bg, and then the number of the job. We can give. Now we see that this command sleep is still running because it is waiting for 200 seconds, and I can send a signal to this process with the command kill. And I also need to give the process ID of the process, the ID of the process. And I get the message that this was terminated. This job was terminated, and with PS list of processes, it is not running anymore. So the command kill sends a signal to the process with this ID. By default, the signal is terminate, or the default signal is terminate. And so the process is terminated. there are several processes that are that we can send several signals that we can send to a process, and we can get a list. We can get a list of signals with kill minus L. Minus L gives a list of signals, possible signals that we can send to a process. And the signal that we send by default, if we don't, the kill sends by default is the signal 15. So if we don't specify a signal, then the signal 15 sig term is sent. And when we press Control C, actually we send the signal number 2 to a process, sig interrupt. And let's try again. For example, let's sleep 200. Sleep 200, and then we are running it in the background, PS. And now kill -2 is this one, sig interrupt. Kill -2, and then the process ID, which is and the process is interrupted. Let's try again to send the signal stop. Kill stop -stop. So we can specify the process minus and then the number of the process, or minus and then this name, the name of the process, stop, and then the process ID is 573. And it is stopped. It is not terminated, because if we see the list, it is still running, or it is still in the list. And if we check the jobs, it is stopped. And we can send the signal continue to a stopped process. So the signal stop is the same as Control Z. Control Z stops on a process that is being that is running. So to continue, we can continue that process. Then we can send to the same process ID this one. See, either like this, signal continue, or like this, or we can send it also like this, sig continue. And if we check the list of processes, then this is running and jobs. Now it is running. Before it was stopped. But after sending it the signal continue, it is still running. And now we can send the signal. Let's send the signal kill, which is actually this one, signal number 9. Or we can do it like this. The signal kill terminates or stops immediately a process. Some of the signals are sent to the process itself, and the process handles them somehow. For example, when we send the signal stop, the process stops itself. Or when we say when we send the signal interrupt, the process interrupts. We are asking it politely to interrupt. But this one, the signal -9 or sigkill, this is not sent to the process. The operating system, when we send this signal, terminates the process unconditionally. It does not ask the process, what do you want to do with this signal, but it just terminates it unconditionally. Now, there is also a command that is called kill all, and then it takes the name of a process, not the process ID. And we can illustrate this command like this. Let's start sleep 100, and then all of them in the background. And then PS, we see there are 3 sleep commands running. And also with jobs, we see that there are 3 jobs running. Now we say kill all sleep. So we are not giving a process ID because these processes have different IDs, but we give the name of the command, and then it is going to terminate. It is going to terminate all the processes that have this name, or that were started from this command, from the command sleep. Now we are going to move to the next topic, which is redirecting standard output and standard error and standard input as well. So first of all, each program in Linux gets some output, gets some input and produces some output. Or maybe it does not get some input, but it produces some output. A program that does not get any input and does not produce any output does not make sense, because it means that it does nothing. It is a useless program. So at least it produces some output. So when we execute a program and a process is started, at least it is going to produce some output. This output is either information that, or the data that the program is displaying, or it may be error codes and error messages in case that some error happens during the execution of the program. And normally these messages, these output messages, are displayed on the screen. And also the error messages by default are displayed on the screen. And usually the input of a program is taken from the keyboard. So when we start a program, if it needs to get some input, then it is getting it from the keyboard. If it needs to print some information, some messages, it is going to print it to the screen. These are called standard input, standard output, and standard error in Linux. But it is also possible to change where the input comes from and where the output is going. And also it is possible to send the output of one command as input to another command. And we can combine several commands like this in a processing chain. So the output of one command goes to the input of one command, and then the output of the second command goes as input to a third command, and so on. First of all, let's see how to redirect the standard output. So I'm running a simple command like this. We have seen this command before. And this command is showing the output on the screen, which is the standard output. But if I want to send the output to a file, then I can use this greater sign, which is called a redirection operator. And then I type the name of the file where this output should be sent. And we see that now there is no output on the screen. But if we check the content of this file, we will see that the output of this command has been saved to this file. And we can check it with less. So we see that here in this file, we have the output from the command. So we actually redirected the output from the standard output, which is the screen, to this file with this redirection operator. Now, let's say that there is a command that gives some error. For example, lsl. This command is giving an error message because this directory does not exist. And actually, the error message says cannot access user bin, no such file or directory. So this is an error message. It is not an output. Now, if we try to redirect the output from this command to the file ls-output.txt, we see that this error message is still displayed. It is not redirected. And if we check actually the file, we see that it has size 0. So it is an empty file. And we can also verify with less that actually it is an empty file. So there are two things that we can learn from this example. First of all, error messages are sent to a different channel, to standard error, not to standard output. So this is an error message. And with this one, we redirect standard output, but not standard error. So error messages are still displayed on the screen. And the second is that this redirection operator actually overrides the content that is in this file. So if there is some content of this file, some prior content, it will be deleted. And then the output from this command will be saved, will be stored in this file. And since there is no output from this command, then we get this empty file in this case. So if we actually want to append the output of this command to this file, we can use this operator. This is a redirection operator, but it actually appends the output to the existing content of the file. It does not delete it. Let's see, for example, what is the size of this file. It is 125K kilobytes. And if I run the command again with appending the output to the file, let's check the size of the file. Now it is 250K. And if I try again and check the size of the file, now it is 374K. So the size of the file is increasing. And this shows that this operator, this redirection operator, actually appends to the existing content of the file, does not delete it. And now let's see how to redirect the let's see how to redirect the error messages or the standard error. The command that was producing an error was this one. To redirect the error message to a file, we can use this redirection operator, to, and then this greater sign, and then the name of the file. Now we see that there is no output on the screen, and if we check the content of this file, we will see that the error message from the command has been stored or has been saved in this file. Now, in order to make sense about what does this mean, this to and then a greater sign. Files in Linux have an identifier which is called file descriptor. So it is a number which is called a file descriptor, and the file descriptor for the standard output is 1. So it is identified by the file descriptor 1, standard output. File descriptor 1. And standard error is identified by the file descriptor 2. And so if we redirect the standard, output, then we use this one. And we can, in this case, we can omit the 1, and it becomes this greater sign. And when we redirect the standard error, then we use this one. So it means that the file descriptor 1 should go to, or should be sent to this file. And in this case, file descriptor 2 should be sent to this file. So hopefully this makes sense, or why we use this to and then the redirection operator. And if we want to append error messages to an existing file, then we use something like this. So to, and then a double a greater sign. And let's check. Let's try it a couple of times, and then let's check the file. So we see that all the error messages are being accumulated to this file, are being appended. And if we use this one, it is going to override the existing content and just append the content, the error message of the command. Now, if we want to redirect both the standard output and standard error to a file, how can we do it? For example, the command I'm redirecting the output of this command to the file ls output. And in order to redirect the standard output to the same file as well, then I can do something like this. And this means that for the standard error, send it to the same place where standard output is sent. So send the content of file descriptor 2 to the same place where file descriptor 1 is being sent. And in this case, we see that there is no no error message displayed because it is being sent to the same file here. So the standard output is being sent to the file ls_output.txt, and then the standard error is being sent to the same place where standard output is sent, which means the same file. Let's check it. So we get the error message here in this file. And actually, the order is important. The order of declaration of these redirections is important, because if we try something like this, so first we are redirecting the standard error message, and then we are redirecting the standard output to this file. But this means that redirect the standard error message to the same place where standard output is being sent. But right here, right now, the standard output is being sent to the screen yet. So the standard error will be sent to the screen again. And then we redirect the standard output to the file. But now it is too late because the standard error is being sent to the screen already. So we still get the error message. Actually, there is an easier way of redirecting both standard output and standard error messages to the same file. And it is by using this operator, this redirection operator, which means that redirect both standard output and standard error to the same file. For example, and then redirect both standard output and standard error to the file and we see that the error message is redirected to this file as well. And also, if we want to append to the existing content of the file, then we use this operator. So this one is appending to an existing file, there is also this file. There is a special file, which is called dev_null. Actually, it is a kind of a device, but if we send something to this file, then it is the same thing as throwing it away. So if we don't care about the error message of a command, then we can send it to, usually we send it to dev_null. For example, ls l in USR, and then redirect the error message to dev_null. So in this case, we are saying that we don't care about the error message, just throw it away, throw it to the trash bin. We said that usually commands get some input from the standard input, and then they send some output to the standard output. A typical command or program that does this is cat. Cat is a shortening for concatenate because usually it can take several files and output the content of these files to the screen. For example, so we are giving as arguments these two files, and the command cut usually outputs the content of the first file to the standard output, which is the screen, and then outputs the content of the second file to the standard output, which is the screen again. But in case that we don't give don't give any files, so if we don't give any files as arguments, then the command cut is going to get the input from the standard input, which is the keyboard. So if we just type cut and then press enter, it is waiting to get some input from the standard input, which is the keyboard. So let me type something hi. After getting the input, it is sending it to the standard output, which is the screen. And now I type another line and press enter. And when I press enter, this line is being sent to the command cut, and the command cut gets it from standard input, which is the keyboard, and then sends it to the standard output, which is the screen. And so we see that these lines are double. The first line is typed from the keyboard, and the second line is the output from the command. And to signal the end of input, or to tell the cut that we are done, the input is finished, we type Control D. So with Control D, usually we signal the end of input. End of input, and then the command cut is terminated. Now we can use this feature of command cut to create simple files. For example, we can say cut, and then we redirect the output to a file. For example, and when I press enter, it is reading from standard input, which is the keyboard. And then I press Control D to signal the end of input. And now we see that this is not displayed on the screen because the standard output has been redirected to this file. And so we should find this to this file. And we can actually display the content of the file with the command cut itself. So the command cut displays the content of the file, so we can display it with the command cut itself. So we see that it actually has been stored to this file. And we can also read the standard input from this file. For example, cut read the standard input from the file lazydog.txt, and it is reading the standard input from this file, and it is displaying it to the standard output, to the screen, which actually is the same as the normal operation of the command cut, which reads the input from its argument files and then displays it to the standard output. Now, I mentioned previously that we can send the output of one command as an input to another command, and this is done with the pipe operator. So it is like a pipe of information. The output of one command goes to the input of another command. Let's see an example. For example, the command it is sending the output to the standard output to the screen. Now we can pipe the output of this command to the command less, and the command less displays it page by page because it was a long output, and we need to scroll to see all of it. But with command less, it displays the first page and stops, and then we can continue to see the following pages by pressing space bar, or we can move with the arrows, arrow down and arrow up, for example. And to quit from the command less, we type Q. We can combine more than two commands with the pipe. For example, in the previous command, we can first sort the output. We can first sort the output of the command ls and then display it with less. And the command sort does the sorting part. So actually, the sorting here is an alphabetical sorting, and it starts from these first characters, which are the same. So let's not make a long listing. For example, ls bin, ls user bin, and then sort, and then less. So we see that the commands that start with A are at the top, and then the commands with B, the commands that start with C, and so on. So they have been sorted alphabetically. But we can also notice that there are some duplicates. So it happens because the same command is in both directories. And so we can, if we want to see a unique list, then we can use the command or the filter unique. And then unique needs a sorted output. So we sort it with sort, with the command sort, and then unique will filter the duplicates, and then we display it with less. And we see that the duplications are removed from the output. And if we want actually to see the duplicate lines instead of the unique lines, then we can add this option -d. This option unique -d is going to show only the lines that are duplicated. So we have this tuner daemon here because it was duplicated. There were more than one lines like this. Also, we had more than one X lines, and so on. So these are all the duplicate lines. Another useful command is wc, which means word count. It counts the words. Actually, so if we count the words of this file, it is giving 3 numbers. The first number is the number of lines. The second number is the number of words. And the third number is the number of characters. We can also do it like this. First, display the content of this file. And then through the pipe, we send it to the command wc. And now we see in this case, it displays also the name of the file to which these stats belong, these statistics belong. But in this case, there is no file because it is getting the input from standard output. So there is no file name here displayed. And the command wc can get some options like -l, for example, if we want to see only the number of lines, and it gives only the number of lines. Or we can say -w if we want to get only the number of words. Or if we want to get only the number of characters, then we say -c. Or we can maybe combine then the number of lines and number of characters. And we can combine them like this as well. So there are some other filters as well, and we will continue with them on the next lesson, since we are almost done. So I see that Anton has some questions, or oh sorry, no, it was a mistake. Okay, so do you have a question so far?
No, it wasn't. I had two windows and I didn't take care to move the cursor, so I wrote it here and I didn't want to do it.
Okay, no problem. I understood it. Okay, so unless you have some questions, then we can stop the meeting for today, and we'll continue on Tuesday. Okay, see you on Tuesday then.